Good morning all. Good morning everyone. Okay, so let's start today's class. So yesterday we are discussing about assumptions for deriving the Euler's theory, isn't it? So basically we derive this Euler's formula or we do this Euler's theory for the long columns. So because long columns will tends to buckle, okay? So that is the reason why we are supposed to derive the derivation for Euler's equation. One second. Yeah. Okay. So just I will revise the topics which we discussed in the previous class. Okay. So guys, so please mute yourself, all of you. So we are discussing the assumptions, right? So what are the assumptions? So just we will read out the assumptions what we discussed in the previous class. So first of all, the column is initially straight and of uniform lateral dimensions, isn't it? So that's the first assumption. And the second one, the compressive load is acting exactly axial and it passes through the center of gravity of the section, isn't it? So that is the your second assumption. And third one, the material of the column is always homogeneous and isotropic. Okay. And the fourth one, what is the fourth assumption? Pin joints are frictionless and fixed ends are perfectly rigid. Okay. So next one, the weight of the column itself is neglected. Okay, we are supposed to neglect the weight of the column. And the column fails by buckling alone. So usually columns will fail by buckling alone. Why? Because so here the column is a long column. Okay. And finally, the limit of proportionality is not exceeded. Okay. So that is what the assumptions which we drawn for deriving the Euler's equation. Okay. So today we are going to see so what is that Euler's formula, how it is going to be derived. Okay. So that's we will see in the today's class. First of all, let me write what is the Euler's formula. So by that we will try to derive that derivation. Okay, how we achieved and what are the parameters involved in it. Okay. Yeah. Euler's formula. Okay. So what is Euler's formula? So basically Euler's formula is going to be used for calculating critical load. What do you mean critical load? The load at which the column
collapse
buckle. Okay, so the load at which column buckle so will be your critical load. Okay, can anyone tell me will your critical load should always be less than or equal to axial load or greater than or equal to axial load?
greater than axial load, sir.
Critical load should be, see, your critical load in the sense the load which is going to make your column buckle. Okay, so your critical load should always be
Greater than axial load, sir.
1 second. So there is some disturbance here. One second. Yeah. Yeah. So critical load should always be greater than or equal to axial load. Then your column is going to be safe. Okay. So this is what you have to achieve when you do your hello. Okay. So this is what you have to achieve when you do your design. Okay. Yeah. So basically, what is your formula? P Euler and a P critical load is equal to pi square EI by LE square. So this is the formula, okay, for calculating your Euler's critical load. Okay, this is your critical load. So where in which, sorry, any doubts, Amma? See, someone is speaking.
No doubt, sir.
Okay, right. So where P is your critical load and E is your Young's modulus. Young's modulus of what? Young's modulus of material. Okay, whatever the material you use for the column, so that is your Young's modulus. And I is your
Moment of inertia.
which moment of inertia? Is it maximum or minimum?
Minimum, sir.
Very good. Minimum moment of inertia. You have to consider minimum moment of inertia. Why? Because minimum moment of inertia leads to what?
Maximum slenderness ratio.
Minimum, first of all, first we have to write radius of gyration. Minimum will leads to minimum radius of gyration, isn't it? R will be minimum. When R will be minimum, when R is minimum,
Slender ratio will be maximum.
Okay, so this maximum slenderness ratio we require to see whether my column will buckle or not. Understand? Okay, so that's why we have to take the minimum moment of inertia to calculate the minimum radius of gyration. Minimum radius of gyration leads to maximum slenderness ratio. So beyond this slenderness ratio, what happens? Definitely the column will buckle. Okay, so to know this, we have to calculate the crippling load, or critical load. Okay, and next one, LE. What is LE?
Effective
Length of column or strut. Okay, anyone is fine. Okay, so these are the parameters of the Euler's formula. So where in which the column of the given length or cross section and the material will have different values of buckling load for different end conditions. As we know, definitely the buckling loads will vary based on the effective length of the member. Even though moment of inertia is same, even though the Young's modulus is same, your buckling load will always differs with respect to effective length of the column. Understand? So very important quantity to be determined. Critical load in the Euler's equation depends on what? It depends on effective length of the column. Effective length of the column will depends on end conditions of the column. Understand? So this is what about the Euler's formula. So let's do one derivation of Euler's formula for different end conditions. If I teach you one based on that, the Euler's formulas will be there for the other different end conditions also. Okay. So before that, let's see what is the limitations for use of this Euler's formula. Okay. So in your competitive exams or in your external examination, they may ask you what are the limitations of Euler's formula. What do you mean limitation? Limitation ante enti? When we have to use this Euler's formula, eppudu vaadali anedi limitation. Understand? So the purpose of using this Euler's formula, 129. Any doubt, Amma? He raised hand. 129. Have you raised a hand? So you are not responding. Okay. Okay. So the limitations of the Euler's formula is very important. Let's see what are the limitations. So there are two limitations, Amma. Limitations of Euler's formula. The first limitation is, so this Euler's formula is applicable to an ideal column or strut. Ideal column or strut, a normal column or a strut. Only in practice, there is always a crookedness in the column and the load applied may not be exactly coaxial. Ante enti? So the limitation is this Euler's formula is applicable for the column which is ideal. Ideal columns ke applicable. But practically speaking, what happens? Tell me. Practically, do you conclude, or can you imagine that load will be exactly axial? Sorry guys, a small net connection problem. Yeah, so what we are discussing?
Limitations of Euler.
Right? Yeah, one second. Yeah. Okay, so let me write it again. Limitations of Euler's formula. Okay, so what is the first limitation entante? For an ideal column or strut, this Euler's formula is applicable. Okay, for which members it is not applicable. Practically what happens, practically the column may not have an axial load. Okay, practically column may not have axial load. Okay, so this is axial load kada. So definitely, practically speaking, column will have the load which is with some eccentrical. So this may be coaxial load ayye chances ekku untayi. Understand? So that is the reason why we have to consider this Euler's formula only for an ideal column or strut. Okay, so which is may not be in practice. Can it practical gain? So definitely practical there is a possibility of coaxial load instead of an axial load. Okay, so this is practically possible. Practical idi jarugutundi. Kani non practical ga ante which is not in practice, we are considering or we are assuming that load is passing through the center of gravity where the load is axial to the column ani manam anukuntunnam. Okay, so that is what the limitation for the Euler's formula. Andarku ardhamainda? Meer anachu, sir, why the load is not axial in the column practically anante? So let us take the whole building. So let us take a 3-story building తీసుకోండి. Okay, can anyone tell me what is the load transformation from top to bottom? Load transformation ఎలా ఉంటుంది ఎవరైనా చెప్పగలరా? Because you are
ఫస్ట్ బీమ్ నుంచి కాలమ్ కి వెళ్తుంది సార్.
your second years, you may not know completely how the load transfers. Okay, but from slab, right, the load will be distributed like this. ఓకేనా, లోడ్ ఈ విధంగా బీమ్స్ కి డిస్ట్రిబ్యూట్ అవుతుంది అనమాట. ఓకే, రైట్. నెక్స్ట్, లోడ్ విల్ క్యారీ బై ద బీమ్స్ ఇన్ దిస్ వే. బీమ్స్ మీద లోడ్ ఎలా ట్రావెల్ అవుతుంది? ఇలాగా ఫాలో అవుతుంది బీమ్స్ మీద. అండ్ దిస్ లోడ్ విల్ ట్రాన్స్ఫర్ టు ద కాలమ్ లైక్ దిస్. Okay, and then column will carry the loads like this. Okay, So in these many variations, do you expect that column will have an axial load?
No, sir.
Is it practically possible that column will definitely carries an axial load?
No, sir.
Anduke, this is practical. Okay. So, but what the limitation is, we are considering column is ideal column, which is not in practice, where column will have an axial load. Okay, manam ila assume cheskuna manam design chestunam. I mean, we are deriving the formula. Understand? So this is very important limitation. Okay. So next one. So what is the second limitation? Second limitation says that it takes no account of direct stress. I mean to say, it gives a buckling load for struts far in excess of load, which it can withstand under direct compression. So that means direct stress is possible in columns and strut. What do you mean direct stress? Direct stress ante entama? The load which is passing through the axis, okay, right? The load which is passing through the axis, so which is parallel to the longitudinal axis. The load should be passes through the axis, and where the load will be parallel to its axis. Okay, so these are all axial force, axial stresses or axial force. Direct stress ante enti? What do you mean direct stress? If it is, if you take the section like this, how your load is? Your load is 90 degrees to its cross section. Understand? So this stress is called direct stress. As we are saying, load always passes through its axis antunnam kabatti, so definitely this load will be perpendicular to its cross section exactly at 90 degrees. So obviously there is a possibility of only a direct stress. Okay, there is no other way of stresses gonna act. So this is also one of the important limitation in the Eulers formula, where the only direct stresses are going to be acted in the column. Okay, which makes your column buckle. Understand? Or which makes your column to have a critical load or buckling load, okay, to make your member buckle. Understand? So these are the two limitations of Eulers formula. Clear, guys? Understand? Rendu limitations ardhamayaya? Guys, have you understood? By that we can start doing the derivation of the Eulers formula. Clear? Guys, please respond. Okay.
Yes, sir.
Yeah. So let's start derivations of Eulers theory or Eulers formula. So let's start first with the first end condition. For end condition, both ends are pinned or hinged. Okay, e end condition ki chedam. Okay, so let me draw the diagram. So this is your column. This end is pinned. This end is also pinned. This is subjected to an axial load, okay, which is in the form of a compression. So let's take the length of the column as L. Okay, so when you apply compression forces, how it bends? It bends from its support This is the bending curvature of the beam. Okay, right. So for derivation, what we do, let me take a distance of x from support B, x. Okay, at distance x, at a section, in the section తీసుకోండి xx అనుకోండి. Okay, the deflection is y. అర్థమవుతుందా? At a section xx, okay, from the point B, the distance at the section is x అన్నమాట. At that distance, the deflection is y. Okay, and the total length of the member is L. Okay, this is the first end condition. For both ends are pinned. Okay, so here we are taking as the column AB of length L, and which is an uniform cross sectional area A, which is both ends are hinged or pinned. So let P be the crippling load at which the column is going to just buckle. So this is your load P, which makes your column buckle. Okay, so we are supposed to calculate what will be this crippling load from this Eulers formula, and which load makes your crippling or critical or buckle ఏదైనా అనొచ్చు మనం. Okay, buckling load అనొచ్చు, critical load అనొచ్చు, crippling load అనొచ్చు. Okay, so that we are going to derive. So for that, what we did, consider a section xx at a distance x from the end B. Okay, so let y be the deflection at the section which is in the lateral direction. Avuna? So this y distance is nothing but in which direction? See, in your column, this is the longitudinal direction. దీన్ని longitudinal direction అంటారు. అవునా? So what is this direction? Lateral direction అంటారు. అంటే the deflection always occurs in lateral direction. Okay, compression will always happens in longitudinal direction. Okay, so that we have to know. Okay, so let me write the bending moment at the section is given by. Can anyone tell me in your strength of materials for calculating the slopes and deflections, which moment equation you have used, Amma? For calculating slopes and deflections, you have used one moment equation. Enta moment equation evarani cheppagalaru?
Double integration method, sir.
Ade enti formula enti? EI of
EI d square y by dx.
Y by dx square is equal to minus mx. Avuna? మీ అందరికి గుర్తుందా? So this is the formula which we have used to calculating the slopes and deflections, isn't it? Yeah, so now we are also using the same. What is mx? mx అంటే ఏంటమ్మా? moment కదా. ఇక్కడ moment ఏంటి? This is the load into distance అంతేనా? Because here the load is acting axially. మీరు అక్కడ strength of materials లో might be you have studied load which is perpendicular to the longitudinal axis kada, but here the load is acting axially. ఇక్కడ ఏంటి moment? Load into distance is moment kada, but here this load into distance is moment. ఇక్కడ moment ఎంత చెప్పండి? P into y, okay, which is in negative direction. So let me write that. EI of d square y by dx square is equal to minus py. Okay, so complete mathematical derivation, so let me do it. Plus py is equal to 0. d square y by dx square plus p by ei of y is equal to 0. Okay, so now the solution for the above differential equation ఏంటంటే the solution for above differential equation ante, so the differential equation దీన్ని మనం differentiate చేసినప్పుడు finally what we'll get, we will get some equation with some constants. అవునా? ఎప్పుడు మనకి ఇది with respect to y లో వస్తుందమ్మా? When you will get this with respect to y, when you do గుర్తుండాలి అందరికీ, నాకు ఇది y ఫార్ములా రావాలి. ఎలా వస్తుంది y ఫార్ములా?
డిఫరెన్షియేషన్.
అవునమ్మా, డిఫరెన్షియల్ ఈక్వేషన్ ఎప్పుడు వస్తుంది ఇది y ఫార్ములా? when you do డబుల్ ఇంటిగ్రేషన్. అవునా కదా? దీన్ని సింగిల్ ఇంటిగ్రేషన్ చేస్తే ఏమవుతుంది? దీన్ని నేను సింగిల్ ఇంటిగ్రేషన్ చేస్తే ఏమవుతుంది? dy by dx. What is dy by dx?
Slope, sir.
Very good. Slope. When dy by dx ని మళ్ళీ ఇంటిగ్రేషన్ చేయండి, ఏమొస్తుంది మనకి? y. What is y?
Deflection.
Very good. Okay, so అందువల్ల I am doing double integration of the above equation, which will be in this form: y is equal to c1 cos x root of p by ei plus c2 sin x root of p by ei. Okay, మీరు అందరూ స్ట్రెంత్ ఆఫ్ మెటీరియల్స్ లో స్లోప్ అండ్ డిఫ్లెక్షన్స్ చేశారు కదా, డబుల్ ఇంటిగ్రేషన్ మెథడ్, మెక్లాన్స్ మెథడ్. ఇన్ ద సేమ్ వే we are doing it. Okay, when you do the double integration of the above equation, you will get finally this equation where c1 and c2 are constants of integration. Okay, those two are integration constants under. So now how to calculate this constants amma? Gurtunna vallu cheppandi, how to calculate this constant? What I have to do for calculating this constants?
Boundary condition.
Very good, very good. Boundary conditions. Good. ఇలాగ మీరు బేసిక్స్ ఉండాలి. So boundary conditions. First take the boundary condition at b. At b, deflection enta 0. Why? Because both ends are pinned. At pin support, deflection enti 0, isn't it? So at x is equal to 0, y ఏమవుతుందమ్మా? 0. By that, what is the constant c1? When x is equal to 0, y is equal to 0, then c1 enta? ఈ ఈక్వేషన్ సబ్స్టిట్యూట్ చేస్తే బౌండరీ కండిషన్స్ c1 ఏమవుతుంది? What is the constant c1 by substituting the boundary conditions as x is equal to 0 and y is equal to 0?
0, sir.
c is 0. Okay, మళ్ళీ ఇంకొక బౌండరీ కండిషన్. At a, the deflection is at a deflection enta? At a
0, sir.
why 0? Why? Because at simply supported beam, at supports deflection is 0, right? At this point, at x is equal to L, y is equal to 0. Antena? By that, substitute these two in the above equation, what you will get? 0 is equal to x is equal to L. What is the value of c1? 0. So this whole parameter will become 0. Kada? Y is equal to 0 is equal to 0 plus c2 sin L root of p by ei అవుతుంది. Okay, so 0 is equal to 0 plus C2 sine L root of P by EI. So this is the second equation with respect to boundary condition x is equal to L, y is equal to 0. Okay. Now, so let me write that. Let me clear it. So since C1 is equal to 0, we conclude that C2 cannot be 0. Avuna? Yes or no? C2 0 avutunda? Why C2 is not 0? Why? Because 0 is equal to C2 sine of L root of P by EI. So when you have this equation, will your C2 will become 0? C2 0 avutunda? Cheptama C2 0 avutunda? No. So by that, this is because if both C1 and C2 are 0, what happens? Column will not bend at all. Okay. So C2 cannot be 0. Kani ikkada oka condition entante, if C1 and C2 becomes 0, what happens? Can anyone tell me when C1, C2 becomes 0?
There will be no buckling at all, sir.
No buckling. Very good. No buckling. Buckling అనేది ఉండదు అసలు. Okay. Buckling జరుగుతుంది అంటే there is some constant which is varying. Okay. No buckling or no bending. Okay. Right. So now let's see this. Hence sine L into root of P by EI is equal to 0. L root of P by EI with respect to sine, మనకి ఎన్ని sine values ఉన్నాయమ్మా? Sine 0, sine pi, sine 2 pi, sine 3 pi, sine 4 pi. Like this we have plenty, kada? Right? So in this what we do is we will take considering the first practical value. Practical ga manaki pi value will be more appropriate. Let us take considering the first practical value which we have is pi. Okay, which is more practical. So by that, L root of P by EI is equal to pi. So then what will be the P value? P ఏమవుతుందమ్మా?
సార్ పైన ఉన్న సైన్ వాల్యూ ఎక్కడికి వెళ్తుంది సార్?
ఏంటమ్మా?
సైన్ వాల్యూ where does it went?
అదే కదా, L root of P by is equal to 0. Sin 0 నే కదా.
Okay sir.
This will become 0. Okay, L root of P by is equal to 0. Not only 0, 0 తర్వాత pi ఉంటుంది, 2 pi ఉంటుంది, 3 pi ఉంటుంది, 4 pi ఉంటుంది. Okay, 0 is not practical, but we can take the practical as pi. 2 pi కూడా practical కాదు, but sometimes it may happen. But practical గా మనకి pi అంటే ఏంటి? What is the value of pi? 3.14, which is 22/7. Okay, so this is more practical, kada? So by that, by considering this value pi, L root of P by E is equal to pi, then what will be your P value? Pi square. ఎందుకంటే just squaring on both sides, two sides squaring చేయండి, ఏమవుతుంది? Pi square EI by L square. అంతేనా? ఇదేనా మనకు వస్తుంది? Squaring on both sides. Yes? చెప్పాలి, ఇదేనా? P is equal to pi square EI by L square. So this is the Eulers formula for an end condition where column is pinned at both ends. Okay? Right? So what is the formula, amma? When column is pinned at both ends, P is equal to pi square EI by L square. ఇప్పుడు చెప్పండి మరి మన యూలర్స్ ఫార్ములా ఏంటి? ఇది కదా అంటున్నాను. ఓకే, we have to write with respect to effective length రాయాలి. When both ends are pinned, what is the end condition? L effective is equal to
L, sir.
L. ఇదే కదా ఎండ్ కండిషన్. మరి నేను ఈ ఫార్ములాను ఎలా రాయొచ్చు? P is equal to pi square EI by L E square. Right, sir? Yes or no? Right? So why? Because when both ends are pinned, the end condition for calculating the effective length is equal to L. So this formula can be written as pi square EI by L E square. Okay, so finally this is your effective, so this is your final crippling load or buckling load. Okay, to calculate, to calculate the buckling load or crippling load with respect to effective length of the column. Understand? So like this, let me write the formulas for all end conditions. Okay, so let's have a table, serial number. ఇంకోటమ్మా ఈక్వాలెంట్ లెంత్ అంటారు, లేకపోతే ఎఫెక్టివ్ లెంత్ అని కూడా అంటారు. ఓకే, ప్లీజ్ యూ హ్యావ్ టు రిమెంబర్ థింగ్స్ ఇన్ 2 ways. ఈక్వాలెంట్ లెంత్ అన్న ఒకటే, ఎఫెక్టివ్ లెంత్ అన్న ఒకటే. ఓకే, నెక్స్ట్ బక్లింగ్ లోడ్ ఆర్ యూలర్. ఓకే, బక్లింగ్ లోడ్ ఆర్ క్రిప్లింగ్ లోడ్ ఆర్ క్రిటికల్ లోడ్, ఎలా అయినా ఒకటే. ఎండ్ కండిషన్, ఇక్కడ ఎండ్ కండిషన్ మర్చిపోయా.
సార్
చెప్పండి అమ్మా.
ఎక్స్టర్నల్ ఎగ్జామ్ లో డెరివేషన్ అడుగుతాడా సార్ ఈక్వివాలెంట్ లెంత్ ఎఫెక్ట్?
మాక్సిమం ప్రాబ్లమ్స్ ఉంటాయమ్మా. డెరివేషన్ అడిగి డెరివేషన్ ఫర్ దిస్ పిన్నెడ్ సపోర్ట్. ఓకే, ఐ విల్ షేర్ ఫర్ ఆల్ ఎండ్ కండిషన్స్. అన్ని ఎండ్ కండిషన్స్ నేను పంపిస్తాను. ఓకే, యూ కెన్ ప్రాక్టీస్. ఇఫ్ దే ఆస్క్ యూ కెన్ డూ ద డెరివేషన్. ఓకే, మాక్సిమం మీకు ఏదైనా యూలర్స్ ఫార్ములాని డెరైవ్ చేయమంటారు. బెటర్ యూలర్స్ ఫార్ములా మీరు కాలమ్ కనెక్టెడ్ విత్ పిన్నెడ్ సపోర్ట్ చేయొచ్చు. వై? బికాస్ యువర్ ఎఫెక్టివ్ లెంత్ ఈజ్ ఈక్వల్ టు ద ఒరిజినల్ లెంత్ కాబట్టి మీరు దాంతో చేస్తే సరిపోతుంది. ఓకే, ఎయిదర్ యూలర్స్ డెరివేషన్ అడుగుతారు, లేకపోతే ప్రాబ్లమ్స్ అడుగుతారు. ప్రాబ్లమ్స్ ఆర్ మేజర్ ఛాన్సెస్ టు ఆస్క్. ఓకేనా? రైట్, ఎండ్ కండిషన్స్ చూద్దాం. Both ends are pinned. Let me write faster, man. Next, both ends are fixed. Third one end is fixed, other free. Fourth one end is fixed, other pinned. Effective length fast చెప్పండి. L by 2,
L by root
2 ఎంత
సార్? పైది 2L సార్. One end is fixed, other end is free. Third one. Third one, sir.
Right, yeah. 2L.
That is L by root 2.
Yeah, L by
root 2, sir.
Yeah.